Welcome everyone. So, if I'm not wrong, this is one of the first, if not the first, meetup, ClickHouse meetup here in Malaysia. I'm very happy to be here. Let's kick off. So, today we're going to talk about ClickHouse and Kafka integration. So, it's not just ClickHouse, not just Kafka, but how we can work well together. My name is Derek, I'm based in Singapore, principal support engineer. So I was asked to put in two fun facts, right? So the first one has to be fun. It's my favorite comedian, he's Dr. Jason Leong. It's my favorite, right? So I watched quite a bit of stand-up comedy, and I really like him. The second one, a fact, maybe not so fun, but I'm born in Malaysia, so happy to be back here, and also to introduce ClickHouse right here. We have KK, who is from Confluent.
You can call me KK because my name is bigger. If you can pronounce my name, it's okay. You can call me Karthik or Karthik or my full name. You just remember me as KK. It's easier to remember me. And the fun facts, I started off as a developer. I was a mobile application developer who has designed the TMB app, right, that you're using. So that was my first project. Then moved slowly to commerce side, which is pre-sales. Now I'm explaining about the solution side of things to the customer. And the second one, hopefully you can see my size yourself, right? So hopefully I'm a gamer. I used to play a lot of games, right? So not the other game, PS5, PS4 games. Right? Thank you. Maybe we will see in the upcoming slides what I'm going to talk about and what is going to talk about. Right? Thank you.
All right, let me start off with some agenda. So I'm going to talk about some introduction to ClickHouse, and then after that I'll hand over to KK, who will give you an introduction to Kafka, that's Kafka 101, and then passing back to me to talk about how ClickHouse integrates with Kafka, and then followed on by some recent improvement because ClickHouse is an open source product. We make active effort to improve our support for a lot of integrations and connector, and Kafka being one. Follow on, the last part would be a demo. So I'll show you how you can connect up Kafka together with ClickHouse, and so that the data will flow into ClickHouse cloud easily. And then we'll do some analytics on there, and that's where you can see some SQL queries. So if you're looking for that, that's at the end. And then we end off with some questions from there. So introduction to ClickHouse. So what is ClickHouse, right? So first and foremost, right, it's an open source product. So it's been developed since the 2009, open source since 2016. That's 9 years, right? And we have garnered over 38,000 GitHub stars. We are very fortunate to have more than 1,600 contributors. We release very often, so you get to see patches, new releases with bug fixes and improvements every now and then. Second of all, it's column oriented, right? So databases, there are many types. ClickHouse is column oriented, and it's meant for analytics query. So best for query aggregations. And then the files are stored in columns. So we do not unnecessarily pick columns that you do not need. Next one would be, it's a distributed system nonetheless, right? So you can run it as a single node. You can also run it in a distributed setup with shards and replicas for high availability. So it's multi-master, meaning to say there's no particular leader or follower. So everyone get to participate in the query execution. Last one would be, it's an OLAP database, storing mostly immutable data, just like a lot of the other OLAP databases. So some of the cool features, right? So first of all, it's SQL, so it's SQL compliant. It's NC SQL compliance to be specific, right? So a lot of the visualization or any other integrations will just work out of the box. Second, it can incur a lot of writes, right? So up to millions of writes per second, and if you were to have a cluster setup, you can increase that as well. Now, thirdly is distributed. So the largest known, at least to me, it's 4,000 servers. I'm pretty sure there are even larger setups out there. Next, highly efficient storage. This is very important because ClickHouse, when you store the data, right, you store it for long, and you want to make sure that it's very cost efficient. And the important thing to do is to compress it really well, not just during storage, but also during reads, right? So ClickHouse take that very seriously, which is why we put there over 20 times compression ratio when it comes to a, let's say for CSV, right? Next, very fast query. So I'll show you later instead of telling you, because a lot of databases would say that their queries are really fast, but I'll show you. Last one would be joins and lookups are something that is also possible with ClickHouse, and we are continuously investing and improving the speed for joins. So what problem does ClickHouse solve, right? So if you need anything to do with real time, right? Real time is just another word for fast, right? Because you have to run the query fast in order to have the real time effect, because otherwise then you will be slow time, right? So, so real-time dashboard, real-time analytics, right? So we are fortunate that Cloudflare, Disney, some of our customers to highlight those logos that you see over there. They are users or even customers of ClickHouse. Business intelligence, so is also a very important. Logging and metrics is also one of our bread and butter, right? Because if you can push in a lot of metrics, push in logs, so that's where you can run analytics and identify intelligence from there. So a newer-ish category would be ML and data science. So ClickHouse recently supports a vector search, right? So you can put in embeddings and do the approximate neighbor search with ClickHouse. So this is also one area that we are constantly investing in. So what makes ClickHouse unique? So as you can see, this is a timeline, right? So over there, those are the slower query. Now over to the right, that would be the lightning fast query. So if you have anything to do with time-sensitive workload, you need high concurrency, right? That's where ClickHouse would fit the bill very, very well. Does that mean that we do not support data lake kind of like queries? It's not. So moving into the next year, we're going to invest in highly in supporting the data lake side of things, which is supporting Delta tables and also Iceberg. That's also one of the important things that's coming up next year. It's also something that keeps me excited, right? Because now we are kind of like covering and widening our use case. So okay, so the points are kind of like largely the same, but I want to point you to the right-hand side, right? So you see two screenshots. These screenshots are available at benchmark.clickhouse.com, right? So benchmark.clickhouse.com is a benchmark that ClickHouse created, but it's not just we create and then we win our own benchmark. It doesn't work like that. So this benchmark is participated by, I believe like today, like 30, maybe even 50 different databases today, right? So it's open source, so we welcome. So let's say if you have a new database that is not already in this list, you decide that, okay, let's run the benchmark and see how well your own database perform, right? So you are free to do that and also submit the results, right? So we will validate the results, make sure that they are reproducible, and then we will put it up there. So you can see that the results are in relative time. You can see that ClickHouse naturally topped the chart, right? So this benchmark.clickhouse.com also has various parameters where you can play with. You can look at the cold run, the hot run, and so on and so forth, right? So that will help you. And also this benchmark is like over like 40 queries, so you can see like which of the queries the other databases are running faster, or maybe ClickHouse is running, let's say, slightly slower. But as far as I know, ClickHouse really performs well on all those, say, 40 queries. Now, okay, another slide on use cases. I think this is kind of like repeated, but so I'm just going to skip. All right, so when I talk about ClickHouse, predominantly it will be open source, because that's the free and open source version of ClickHouse, right? Anybody can make a pull request. You can contribute to the open source ClickHouse. In fact, we want more contributors to participate in developing ClickHouse. We are also having a very active discussion and also issues. So anybody found any bug, you are free to create an issue. So we welcome them as well. So again, we hit over 200,000 active community members, so you can see that the pull request is actually hitting very high. Now, on the bottom side of things, that would be ClickHouse Cloud, right? So you must be asking, so what's the difference? I mean, open source and then you have cloud. Does it mean that you take the open source binary and then you just deploy it in the cloud environment? It's actually not that. So in my next slides, I'm going to tell you more about like the design consideration when we come to a cloud. Yes, let's move. So on the left, this is where you have self-managed, right? So in a self-managed cluster, what you can do is that you can divide the data into shards, right? So that's where one shard cannot hold all the data, so you have to really split your data into multiple shards. And then you can have replicas, right? So you can see R1 to R4, those are the replicas. Again, this is really the self-managed setup. You can take a single binary, run it on all those servers, and then set it up in a shard and replica setup. It's all free, you don't have to pay us a single dollar. And we see many success stories in the self-managed side of things. Now, on the other hand, right, so this will be the cloud setup. Now, the cloud setup doesn't make use of the shard concept, because the reason why we need shard is because a single node has very limited disk that's being attached, right? So last I know, AWS has like maybe 16 terabyte or even more, for example, right? There's a number to it. On cloud, on the other hand, right, we make use of object store, right? So object store has unlimited storage, which it is. That we found. So that's the difference in terms of architecture. And also more importantly, because now that we are using object store, the compute and the storage are being separated, which also means that you can add more compute if you have higher requirement in terms of workload. So it can scale, I would say, unlimited also in terms of the replicas, and scale linearly, right? So as opposed to a self-managed setup where you need to just add new nodes, maybe do resharding, and so on and so forth. So we remove the pain away from the self-managed kind of like architecture. And also more consideration that I may not have time to touch on today. That's also in our cloud product. So yes, so when it comes to integration, with ClickHouse takes integration very seriously, because we are ultimately a database. We need to work with a lot of partners, right? So our upstream and also our downstream being the visualization and dashboard. So it's ever growing, yes. So one of the really like top requests is to have a good Kafka setup, right? So, and this is also where I'll pass the time to my friend KK, who will talk to you about Confluent.
Thank you. Hello. Yeah. So, before we start off with this, right, I would like to ask you a few questions. So, how many of you skipped your gym today? How many of you skipped your dinner today? No, yes. It looks like nobody had dinner, so it's like quite very late.
We're gonna have dinner after this.
Oh, okay. So you must be boosted now, right? I don't know what's the menu, but it should be some delicious food. All right. So just few hours, bear with me. So what I'm going to tell about is, before we cook something, right, we need to know what's the ingredients in it, right? So that's why I'm going to talk about Kafka. So before I talk about Confluent, right, what is Kafka? So Kafka was born in 2010, and it was originally created by LinkedIn by our Confluent founders. Let me show the photos of the founders as well. There's a beautiful photo there. And slowly, we have involved in the rise of event streaming. So whenever I talk about events, right, you can imagine like ordering a food or ordering a crab or any things that you do day to day. You order a food, and let's say your Grab driver is nearby your home. Of course, the human mentality, every time I go out and then check out my driver is there or not, whether my food has arrived or not, right? So that's the human mentality. If your data is delayed, let's say my Grab driver already arrived, but my phone is not updated, right? Then you get pissed off. Hey, why is it? My Grab driver is somewhere else and my phone is showing somewhere location. So those are some of the events you can compare with, right? And Confluent has built a wrap and a certified platform, I would say, on top of the open source Apache Kafka. And 80% of the companies, 80% of Fortune 500 companies are being used with event-driven architecture and event streaming platform. So that's where we play a major role there. So these are our founders, which is Jay Cripps, CEO of Confluent, and Neha Nakul, and Jun Rao, VP of Engineering. So you can see the multiple logos here. So these are our trusted customers, and these are, I would say, trusted guys who has tasted our recipe. right? You can see that founded and originally created by Apache Kafka. So we don't claim that we have created, it was originally created by Apache Kafka, and then we have certified it and then given to the enterprise customers. It is like enterprise certificate wrapped to get on top of the Apache Kafka, right? Okay, let's talk about Kafka. So now I'm going to talk about ingredients. So Kafka is a distributed commit log, so it's like an appending of every event. Event is basically whatever you send or whatever you talk, that will be stored as an event. So event contains two major things. One is key and value. So if you look at the picture there, right? So it's everything is appending only. So it's not overwriting, it's appending. So if you look at the overall architecture of Kafka, right? So it looks like this. So in between you can see a Kafka cluster, and there is a producer and consumer. So producers are the one who generates the data, and consumers are the one who takes the data. So publishing the stream events is from producer side, store, and you can do whatever you wanted in the Kafka cluster. You can either edit the data, update the data, run through the data, insert the data, or you can modify the data, and you can combine the data, merge the data, whatever you can do, you can be done inside the Kafka cluster. Right? And produce and consume. So the process will be taken care, and then consumers can consume with the different formats of different locations. Right? So this is the basic concept. Right? So producers, consumers in between the Kafka cluster. You can imagine like you are ordering your food in a restaurant, a waiter comes and takes in your order, and then goes, grab the food, and then come to you and give it to you, right? So it's the same concept. Clear? This is the concept. So inside the concept, right, we call topics. Topics is basically the events. You can imagine as a database table. So topic is the main concept. So whenever we talk about Kafka, right, we talk about topics. So what is topics? Topic is an event actually, event store actually. So Kafka topics is something like this. But if you look at in your code, right, it doesn't look like this. So it's like I'm giving you the ingredients inside Kafka topics, how it is being stored and how it is being segregated and how it is being used. So Kafka topics, when we create, right, we create a replication factor and partitions as well. So the best practices to create the partition is more than one. And if you have only one, no, it's not good. But for the example, you can create one only. Right? So in order to manage your data and data replication or scaling, it can be used. So this is the structure. Your partitions will be starting from 0, and these partitions will be taken care by the broker, because broker is considered like you're having different systems inside, and each system is holding one partition. So if one broker is down, the other will be taken care. So it's like a similar concept in the Kubernetes. So if one pod is down, the other will be taken care and then right through it, right? So it's the same concept. Right. So how does the Kafka produce the resilience? Is basically, I said about the broker, right? Each one is one of the system, and each one will have one leader. So that guy will take care of the actions and what needs to be done with the followers. So it takes the data and then produces the data and then gives to the followers. So each broker will have one leader, and followers will be upcoming. So if you look at topic 1 and partition 1, right, it is stored in broker 3 and broker 1. If one is down, the other one will take it care. Right? So let's talk about producers. So if you look at the code, right, I hope you can see my screen. So this is the code actually. So we just focus on only this line. So this is a guy who sends the producer data. So this producer data is taken from input file, which is there, input.txt. So that's the file I have given. So this file, these are the data that needs to be sent to the consumers. Just an example, like I generate the data and someone has to consume it, right? So this is the generated data. Once I start the code, sorry? Oh, right. I thought some question is there. So after I run the producer code, right, what happens is it generates the data at the consumer side. So every time I generate, it append the data. So you can see multiple data that's been generated. I run the code 3 times. and 3 times the data has been recorded. So you can see multiple times it has been appending. So every time it is not deleting, it is appending. And you can create the best part is there is a retention time, and you can store the data for some amount of time. Right, so let's see what is inside that code itself. So if you look at the producer diagram, right, so what happens inside the producer is basically your record will be stored as, you can see there is a key, and before I go there is a key, right, key and value. So the key is a major thing to store data. So whenever your key is like A, B, C, and if your A is stored in partition 1, the A follows to store in the partition 1 itself. And it follows the key actually to store inside the partition. It's like a unique key valuable to store inside the partition. So that's how it works. And this is the structure of your partition. And whenever you send the data, the serializer and partitioner is the major one. So what these two guys does is, the serializer, it can be any code that you have. It can be JSON or CSV file or whatever format you are sending into the serializer. It can convert to bits and bytes. So if it can be converted to binary, then you are good to go. It doesn't matter whatever your source is there, right? So if your byte matches and then you can convert to a binary file, then it's fine. You can send your data. And this serializer code, so this is a serializer guy. So this guy, what it does is it changes your record to bytes and then send to serializer to convert it, right? So this is how it works. So whenever your key has some values, it matches. If your key doesn't have any values, it just follows the round robin fashion. It just stores like this. So for example, if it is, there is no key there, it just stores as round robin fashion. If, sorry, let's go here. Yeah, there is a key here. It stores A and then B at the second. If again A is there, then it goes to the first file, the first partition itself. So this is how it's stored inside the producers. Right? So this is the basic concept inside the Kafka topic. Don't get imagining like, this is a concept alone. It's not like a working example that you wanted to do, right? So this is a concept that just understand it, that's it. Let's go to consumer side. So consumer side, this is the code, and this is how you write the consumer side. Whatever your producer is producing, right, there has to someone to consume it. So this is a code bit, and if you look at here, there is a record consumer report. So how much time it required to consume it, like 100 milliseconds you wanted to consume it, or whatever time you wanted to consume it, you can put it there. So this is a code for that. So consumer can be a group of customers, or group of consumers, or an individual consumer from different partitions. So the best part is, let's say you have different sources. For example, you have a database like Postgres, MongoDB, or whatever sources is there, right? You take from there as a producer, those are our producers, and from the consumer side, you can put it in any of the analytics tool. So it can be BigQuery, or it can be Tableau, or whatever you have, the analytics part, right? You just need to put it there. So in our case, ClickHouse will be there, right? They are the consumers, right? So we are the producers, and then there is one more concept called connectors, so I'll be going there. So for now, if you talk about Kafka, there is producer, consumer, and Kafka cluster in between. So if you take from source to the destination, how the data has been moved from one to other. So that's how we do, and it is more real time. It's not like data at rest, which we store inside the data and then consume it. It's data in the motion, right? So let's go here. There's something called offset. So offset is something called, once you consume it, right, you should acknowledge that I have consumed, right? So that's called offset. Offset is there in topics as well, producers as well. So once you consume it, how much time it has to be there, and if it is failed, then the offset has to be changed. It has to retrieve the offset value. So that's something important that needs to be known. And this is what I was saying. There is a connector in between. So whenever I produce and consume a data, right, there is a connector between to retrieve the data and put it inside Kafka cluster. And then from Kafka cluster, there's some guy to put from Kafka cluster to the consumers. So that's called connector. So for this connector, you don't need to write any code. So Confluent has done a good job where we have 120 plus of connectors which is certified and fully managed connectors, which is available in the cloud version, not the on-premises version. So this is what it does. So from your source, it connects and then put inside the cluster, and it can sync back to your wherever your data sync is there. So this is the concept from the connectors. So when we talk about the upstream and downstream, right? So we have this points which has to be highlighted, which is one is the capture part, where your schema registry stores your data, so we don't have any data loss that's there, and highly available and extensible. So it can be extended and it can be sourced to any of your source to the destination, any of the destinations, right? So it's a reusable concept, reusable component as well. So it can, like, if you have one time ready, and then it can be reused multiple times. You don't need to rewrite anything, so it can be reused again. So the formats that you can consume, it can be JSON, Avro, and others as well. So there's under the JSON, under the Java file or under your JavaScript or Python, right? You can consume it in different formats. So those are the formats. So the best or the popular ones are JSON and Avro. So those two are popular in consuming. Right, so in between, when you consume your data from source to destination, you can transform your data. So like you can append from multiple values. Let's say you have your user record in your database A, and then you have your user credit details in database B. You can combine or union it and then consume it while you are transforming the data from one source to the destination. So it's like on the fly, you can append it and then consume it at the consumer level. You don't need to write a special code to combine it. Right, so any questions on the developer side, you can go to developer.confluent.io. So a lot of examples is there, a lot of use cases is there. Like from banking side, different verticals have different use cases, like financial, telco, manufacturing, and a lot of industries use cases are available. It's already built. There is a template available. You just need to sign up, and 400 free credits is there under Confluent Cloud. You can use it, right? Thank you. Any questions? No? Thank you.
All right, thank you, KK. So let me continue with the presentation. So KK gave you a very good tool about Kafka 101. So now let me tell you more about how you can now integrate ClickHouse with Kafka, right? So, so first and foremost, ClickHouse loves Kafka. And why is that, right? So make a guess. It's because both are real-time systems, right? So what better way to pair one real-time system with another? So that's how it flows together. So this slide is really more about what are the existing Kafka integrations, right? So in general, we have three ways where you can integrate Kafka with ClickHouse. Now, let me just go through one by one. The first one is really simple SQL. This is a create table command. Now what this means is that we do support Kafka as a table engine, meaning to say you can create a table, as you can see, and point the engine to Kafka, right? You can see the connection string, the topic, and so on. So once you do that, it just means that the connection is up, and the next thing you need to do is to add a materialized view that reads off this Kafka table engine, and then insert your data into whatever target table that you want, right? So this is how you can make a connection directly to with Kafka just by using SQL commands, right? The second one, slightly more complex, but rides on the concept of a connector that KK just mentioned. So ClickHouse Kafka Connect Sync. This is something that we developed. It's supported by ClickHouse, and that is also another one that we recommend you trying out. Obviously, you can also use it through a JDBC connector or even a HTTP sync. So ClickHouse also talks HTTP, right? So you can also send data or even run queries on our HTTP interface. That's the second one. The last one, this is ClickPipes, right? So ClickPipes is available in ClickHouse Cloud. So this is even a more simpler thing to use. And this is also what I will be demoing to you to show you the simplicity. What happens is that you put in a few credentials, and then the data will just flow in, right? So again, I'll leave the goodies to the end. So let me first talk about the Kafka Connect Sync, right? So Kafka Connect Sync, so if you need like exactly one semantic, right? So you can consider using the Kafka Connect Sync because that's the Kafka Connect Sync on the second one, because the first one, Kafka Table Engine, doesn't support exactly one semantic up to recently. I'll tell you the new development that we have since a couple of months ago. Right? Because right now, with the experimental feature, you can also use Kafka Table Engine and also guarantee the exactly ones. But up to then, unless that goes into GA, which we have intention to, that is at least once, right? So Kafka Connect Sync exactly once. If you need that, go for it. So that uses a feature, not so much of a feature actually, it's also yet another table engine called a keeper map, right? So a keeper map is a table engine. Now it's used to store the state, right? So if you need, because you want to keep track of the offsets, so and you want to allow the linearizable writes and also sequentially consistent reads, then that's where keeper map will come in. So this is a bit technical, bear with me. Now this Connect Sync is also supported by ClickHouse, right? So any bugs, problems, we will fix that. The data insert can also be as declared schema, as what KK has mentioned. So if you want schema-based data, if you have, Arrow, protobuf we support. Otherwise, schemaless such as JSON will also work. Now let me spend more time on ClickPipes because this is on ClickHouse Cloud and it's also really easy to use. So it provides a cloud-native experience for you to ingest data from remote sources to ClickHouse. Not just from Kafka, but also from other sources which you will see when I show you the screenshot. So today the focus will be ClickPipes for Confluent Cloud, right? As you can see from the upper left screenshot, we also support the other sources, Postgres, CDC, even from Object Store. You can define a path, create a ClickPipe, and then watch over a path. Any new object that gets added will automatically be ingested into ClickHouse. But again, today's focus is on Confluent Cloud. So you can see these are literally just 3 steps, right, which I will show you in a bit. So defining the credentials, checking that your data actually flows in, that's the one in the middle, and then lastly would be creating a table so that your data will land on whatever target table that you define. Now, I want to also take some time to talk about some recent improvements, right? So when I say ClickHouse is also investing in a lot in Kafka. So these are the bug fixes, improvement, and also the topmost is the experimental feature that I was talking about. So with the experimental feature, you can now store the offset in Keeper, right? Instead of relying on commits on the Kafka side of things. So why is this important? Because over at 24.8, right, so we support exactly once processing of Kafka messages, right? So this is thanks to the new Kafka improvement on the table engine side. So to do this, you have to allow the experimental setting, and after that, define the Kafka path, right? And let me just go through, yep. And then the last one would be like, yep. And with this entirely all set up, it enables the deduplication and also guarantees the exactly one's behavior. So that's that. Now coming to the demo, I am going to show you, okay, I need to switch the laptop. I'm going to show you how ClickPipes can work well with Kafka and flow data through to ClickHouse. So give me a moment. Okay, I'll try my best to face you guys and also show you. Okay, so what I have ready today, it's a Kafka Confluent cluster, cluster that already has a connector being added, right? So this is a data gen, so it generates sample data, feed it into the Kafka cluster, and then from here we can see that we already have some data coming through some 6 partitions, 1 topic, right? So from here, what we need to gather is the API key, which I have already pre-defined. The other thing is the server endpoint, right? So this is where I have also copied into, let me see my notepad. over here. So API key and the endpoint is all you need, right? So let me go to, so this is ClickHouse Cloud. Is it too small? Maybe I'll try to make it larger. Better? Okay, so this is ClickHouse Cloud, right? So in order to make a connection, you can go to the left-hand side. This is the data sources. So over here, you have a large button inviting you to set up a ClickPipe. So as you can see, other than ClickPipes, you can also upload a file, put in a file URL, or even get started with some sample data. Now today, we're going to create a ClickPipes on Confluent Cloud. So I'm just going to go ahead and click here. I'm going to put in just a name, and also provide the key. Just these few things, and we are all set up. Okay, just 3 things. And next, ClickPipes will go ahead and make the connection with the cluster, and after that, you get to choose the topic, right? So I already have a clickstream topic all set up from the data gen. From the offset, we will read everything from the beginning. And let's see, okay, so this is a sample message, right? So we have the time, agent, bytes, IP address, request. Quite a bare bone one, but a functional one. I'll show you what we can do with this when you have a lot more data when it comes to aggregating it. So next, we parse the data. And then, so this is how it looks like. So it's going to tell you, okay, now you do not have a table, maybe, and you can create a new table if you want, right? So we're going to go ahead and create a new table. And so this is the sorting key that you need to define. So sorting key, which is also a primary key, is very important. In ClickHouse, it helps you filter as much data as possible so that your query will run really fast. So you just choose 2 sorting key, and then these are the columns that are being detected. So it's automatically detected, and if you want to change the type, you're free to do so. If you want to add a column, you can as well. So basically, what I'm trying to do is to add in a virtual column that comes with the Kafka message. So I know this is a date time, right? So if we go back here, we can see the message. Let's see, messages. Over here. So essentially, it's actually reading the message that we have here, and I'm including the timestamp. So let's click next, and then let's give it a permission. You can have everything, and then we will complete the setup. So after completing the setup, we will see a new pipe being created. The name is called pipe. The type is Confluent Cloud. So you have a lot of pipes. It will all be listed here. Now let's give it some time. It is currently provisioning, and then we will go in and check the details. Good, now it's running. So over here, you get to see a lot more information. So one is the pipe ID, the status, number of records that is reading, and I think importantly, this replica, it's something that you might be interested. So what I have put in is, if you recall, this is I think 6 partitions, right? So ClickPipes also support scaling, because by default it's just one consumer within the consumer group. What you can do is that you can increase the number of replicas to match up with the number of partitions, right? So that you get the full throughput. So what I'm going to do is I'm going to also click apply. So when you do this, it will scale up on the fly. So yes, this is ClickPipes scaling up and reading from the 6 partitions that I have. There are also some metrics that you can monitor. So seems like it is reprovisioning, but I think we should get there really quickly. So let's just check the table, right? Oops. So now we have the table up and running. Let's see if we see any data. Yes, we see data flowing in, right? So if I were to, so I already have like 30,000 rows. If I refresh, so I should see the number of rows going up. Yep, it is going up, as you can see from here. Now, 30,000 rows isn't really very exciting. So I have pre-prepared another table, also very similar schema. In fact, I think it might be the same. It's called clickstream_all, right? So before I dive into, so let me just show you the data that I have over here. So this is 295 million rows. Good enough, but I mean, it's good enough to run query fast-ish. So I mean, I intended to put in billions of rows, but I ran out of time when I tried to load in the data. Now, I want to show you what you can do with all these data, right? So I'll show you the nice stuff first. So we do have a new feature where we add in a dashboard within ClickHouse Cloud. This is in beta. So if it breaks, contact my product manager. But I have prepared quite a, I believe, nice dashboard. I've done this in 30 minutes. You can do it as well. So we can see that the total number of requests this week and today, right? So it gives you a very nice display. Now, you must be wondering, this must be powered by some queries, right? So the answer is yes. So what kind of queries are we looking at, right? So the queries are all pre-saved in here, right? So if you look at row count, I can click run and you can see it's going to return 295 million rows. Now let's find something more challenging, right? So let's say I want to find, so aggregate on agents, right? So this has 295 million rows. I'm going to group by all, which is group by agent. I'm going to check count, basically tell me each of the unique agent, how many counts are there, right? I'm going to run this across 295 million, and you can see the elapsed time is less than a second. In fact, this is 637 millisecond, and we can see that it is reading 295 million rows. And also, not to mention, sorted by count, right? You can already see from here. So to me, this is quite fast. And you can see that the other relevant queries, so this is about hourly count, right, row count, so you get to see this pattern like that. That's also because I inserted data to be of this shape. What else do I have? Yeah, so let's see if I have more challenging query. I might have, or let me see. Yeah, I think this is really a rather simple one because the dashboard says everything, right? So this is aggregating on an hourly basis, showing you the count. This is looking at the top requests. You also get to see the count, HTTP code as well, and also below I put in a table filtering out all the status code that's not 200. So maybe these are the ones that you might want to see, right? So again, this is a very simple dashboard. We work well with Grafana. So with pairing with Grafana, you get to unlock a lot more capabilities, and the queries from Grafana will be sent and executed by ClickHouse. You get a more I would say a more holistic dashboard, and whatever visualization needs, it's supported there, right? We also support Tableau Cloud as well, if that's something that you're using. And with that, I think that's the end of my presentation. So that's all I have. Thank you, everyone.